Sharp Bafetu Ninjani. I hope Nyapila. So in today's video we're going to be focusing on the summation notation, or rather what most people call it the sigma notation. So before I can explain what the sigma notation indicates or implies, let me first explain what the notations that are in the sigma mean. Right? So we have the K. This is what the index of the summation. And then we have M. This represents the lower bound of the summation. We have N. This represents the upper bound of the summation. And then you have what your TK. This represents what the terms in the sequence, or rather you can say or call it what the representation of the general term of a given sequence, right? So what mainly the sigma notation indicates, it indicates that we should sum up the expression written to the right of it, right? So we sum this expression from the lower bound M to the upper bound N, right? So the index K is increased by increments of 1 from M until we go to the nth value. What do I mean by that? So for me to go from M to N, remember that I should sum up what the expression written to the right of the summation, or rather the sigma notation. So I should sum it up from M to N and increase it with increments of 1. So this is how it looks like. So it's going to be T, and then the index is going to be replaced or substituted by M. So this would be M plus, remember I have to increase from the lower bound M to the upper bound N. And then the increment will be just 1. So this will be Tm plus 1 plus Tm plus 2 plus all the way to the nth term. So this is what the sigma notation indicates, right? So let's say now our M value, or rather our lower bound, is equals to 1. So we'll be writing our summation as this. So this would be the index K equals to the lower bound N all the way up to the nth term. And then given the terms of the sequence as TK. So what you should notice, guys, is that if the index is K here, also the expression that is written to the right of the summation and notation should also be in terms of K, right? So if our lower bound is equal to 1, the sequence will start from 1 to N with increments of 1. So we'll have T1 plus T2 plus all the way to the nth term. Sharp. So now that we have done the explanation, let's get to do our questions so that we get a better understanding of the sigma notation. Remember what it indicates, right? It indicates that we should do what? We should sum up the expression written to the right of it from the lower bound to the upper bound. We increase from the lower bound to the upper bound by increments of 1, right? So let's look at the first one. So the first one, it has an expression of K squared to its right, and it has a lower bound of 1. So which means we're going to substitute the index by 1, and then we're going to increase by 1 until we get to the nth term, right? So we will substitute 1. This would be 1 squared plus, because it's a summation, 2 squared plus 3 squared plus 4 squared. This will go all the way to the nth term, which is n squared. So you can simplify this. This is 1 plus 4 plus 9 plus 16 plus all the way to the n squared. So this is what it means to expand from what? From the given sigma notation. Let's look at the second one. So again, we start from what? From a lower bound of 1 to an upper bound of 6, right? So which means where there is K, we're going to substitute 1 and then increase by increments of 1 until we get to the 6th value. So this is what we have. This would be 1 over 1 plus 2 plus 2 over 2 plus 2 plus 3 over 3 plus 2 plus 4 over 4 plus 2 plus 5 over 5 plus 2 plus 6 over 6 plus 2, right? So you can simplify this. You would have what? You would have 1 over 3 plus 2 over 4 plus 3 over 5 plus 4 over 6 plus 5 over 7 plus 6 over 8. So we have moved from what? From the lower bound 1 to an upper bound 6 with an increment of 1 in each of the terms when we sum up. Hence we have 1, 2, 3, 4, 5, 6. Also in the here in this part we have 1, 2, 3, 4, 5, 6. Sharp. Let's go and look at the other part. Again, we have to expand this one. So here we are starting from what? We are starting from the lower bound 2 up to the upper bound 5. So which means everywhere where there is r, we'll start from 2 and increase again by an increment of what? 1. So we'll have 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5, right? So if you check here, we have summed how many terms? 4, right? Because we have started with the lower bound of 2 instead of starting with the lower bound of 1. Another way that you can find how many terms you should sum up in the sigma notation is by subtracting the upper bound to the lower bound and add 1. So in this case it will be 5 the upper bound minus the lower bound 2, and then we add 1. This will give us what? So 5 minus 2 gives us 3 plus 1 gives us 4, which means we have to sum up 4 values in the given sigma notation, right? So let's go and look at the last one. Let me image this. So again, in this one we are starting to sum from an index of 3 up to the upper bound 10, right? So we are expecting to sum up how many terms? So it's going to be 10 minus 3, so it's upper bound minus the lower bound plus 1. This will give us what? 10 minus 3 is 7 plus 1 8. So we're expecting to sum up what? 8 terms from the lower bound 3 to the upper bound 10. So this would be we have r plus 1, so this would be 3 plus 1 plus 4 plus 1 plus 5 plus 1 plus 6 plus 1 plus 7 plus 1. Continue here, plus 8 plus 1 plus 9 plus 1, all the way to what? 10 plus 1. So we have expanded by doing this. So you can simplify this for yourself. This would be 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So we have summed up how many values or terms? It's 1, 2, 3, 4, 5, 6, 7. So plus 11. So this tells you how many terms or values you should sum up, right? Remember, we increase the index from the lower bound to the upper bound with increments of what? Of 1. Sharp. So we're going to do Amayama questions that concern what? Sigma notation. Remember, we haven't gotten into sigma notations that require us to focus on arithmetic series and geometric series. It's just an introduction of what? A sigma notation, just like we did in the previous video with the series, right? So this question will focus on what? Moving from a series back to a sigma notation, meaning that we have to write a series in a sigma notation, right? So let's look at these questions on the board. So they say here, write the following series in sigma notation. So we are given a series which is from 11 plus 22 plus 33 plus 44 plus 55. So in order for us to be able to write a series in sigma notation, the first thing that we should be able to do is be able to write the expression, or rather the general term of the sequence, right? So if we look at this series, we can tell that it is made up of a sequence that is 11, 22, 33, 44, and 55, right? we can tell from this that this is an arithmetic sequence, right? But again, we can see a pattern here. To get the second term, it's the first term multiplied by 2. To get the third term, is the first term multiplied by 3. The fourth term, we multiply the first term by 4. The fifth term, we multiply the first term by 5. So we can conclude and say that the general term of this sequence can be tk equals to 11 multiplied by k, right? So this gives us what? The general term of the sequence. And again, we can see that 5 terms were summed up. So it can be from what? The lower bound 1 up to an upper bound of 5. So therefore, the sigma notation of this series will be k equals to 1 up to 5 with the general term of 11k. Sharp.